this video, we're going to talk about how to find proportions in the normal distribution. So we're going to take normal curves, and we're going to find proportions under the area under the curve that's between 2 points in an interval. So this is the basic overview of how we do it. We'll take it step by step, but here's your basic overview. We're going to take the observed values of the endpoints in the interval of interest in our normal curve, whatever mean and standard deviation that has. And we're going to convert those to standardized scores, which we call z-scores. And then we can use something called a normal table to find those probabilities of proportions. And I'm going to show you how to do this on the table. It's key to understand how the table works and to understand this conversion into the standardized scores. But we're also going to talk about doing things on the calculator because, quite frankly, we have a lot of rounding errors when we use the table. And so in a practical sense, it makes more sense to use the calculator when we actually calculate the answers to problems. So here's how it works. How to standardize a normal curve. The z-score is found, and that's what standardizing is called. We find something called a z-score. And the z-score is that. And we find it by taking x, the data value in our distribution, and plugging into the formula with the mean and the standard deviation, mu and sigma, from our distribution. We have to go back and make sure that you get a chance to pause on this and get that down if you don't have it down. And I'll go on. Okay. So here's an example. We're going to look at IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. This example is going to come up again and again as we work through things. We'll use the same distribution. We want to know what's the standardized score for a person whose IQ is 85 or for a person whose IQ is 130. We'll do 85 first. We just plug into the formula. And when we do all this arithmetic, we'll end up with a z-score of -1. It's one standard deviation below the mean. We'll do the same thing for 130. We plug it into the formula and we get 2. 130 is 2 standard deviations above the mean. And that's what the z-score is really telling you. So let's suppose that IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. How about if we go backwards? How about if we have the standardized IQ score at -1.57 and we want their actual IQ score? In other words, we want to know the IQ score that's 1.57 standard deviations less than the mean. Do the same thing. We use the same formula. It's just a different variable we're solving for now. A little bit more of the algebraic gyrations, but we end up with 76.45. Okay, so we're finding areas under the standard normal curve. It's really not the z-score that's the most important thing. It's just a step to get us there. The point is that the area under the curve in an interval is what's of interest to us. And because that indicates the proportion or percentage of the population falling in that range. It's all about finding really a probability that this happens, that you get somebody there, or a proportion of people that are actually there. So let's talk about using a normal table because that's how we find these areas. Basically, before we had calculators, everyone always used the normal table. We didn't have these graphing calculators that did these fancy things. And the whole point of standardizing is because you didn't want to have a table for every single possible normal curve you could have. It would be impossible. But if we have one table for the standard normal and we can make everything into standard normal by standardizing, getting this z-score, then we only need the one table. Brilliant. So we want to know the proportion of the population of people who have an IQ test score less than 76.45. Well, we've already figured out the z-score. So if their IQ score is less than 76.45, their z-score would be less than 1.57. We're looking to the area of the graph left of that. So here's our standard normal, and there's 1.57. We need to find out what proportion, what's the area under the curve here. So we're going to use this normal table. Now there's a copy of it in the course. I want you to print it out and keep it with your stuff. And I know it's teeny, teeny, tiny on here. Okay? So I'm going to kind of show you the overall of what it is. But let's go. I'm going to zero in on what we're looking for. And you'll see that the top row gives you, it's the z-score down here, and then this tacks on the hundredths place. So negative 1.51 is this. We want negative 1.57. So we go down to where those cross, and we get 0.0582. That tells us that about 5.82% of the population have an IQ score less than 76.45. So moving on about how to do this under the standard normal curve, I want you to pause the video and look on the normal table and figure out what the area is to the left of 1.75. Okay, you should have looked on your table. You come back, it's 9.9599. How about the area to the right of 1.75? Well, pause the video and think about it for a while. And when you think you have an answer, come back. We know if we have the area to the left being 0.9599, to the right has to be the rest of the whole curve, and the whole curve is 1. So 1 minus the 0.9599 gives us 0.0401. So always make sure you know whether you want the right or the left, because if you want the right, you're going to have to subtract from 1. The table always gives the left. So here's an example. I've drawn a picture for you. I want to dissect this picture with you. You need to draw this picture every time you do a problem with a normal curve. You need to draw a picture that looks like this. You'll draw the curve itself. You put the mean on and mark where it is. Here we're on a standard normal, so it's 0, 1. Okay. And then I have my endpoints, negative 2.13 and 1.09. And I need the area between that. Well, to the left of 1.09 goes from here all the way back, including this tail. But I don't want that tail, I just want to go that far, so I need to subtract out that little tail. So if I look up 1.09, I'll get 0.8621. And if I look up negative 2.13, so I can figure out what that tail is, that'll be the area that I have to subtract off. It's 0.0166. And I do that subtraction and I get 0.8455. Okay? Always be drawing that picture. Now I want to look at the IQ data, the normal distribution, mean of 100, standard deviation of 15. To find the IQ score at the top 10%. So at what point do we have only 10% of the population scoring higher than that? Well, again, I draw my curve, I put my mean on, I mark what my curve is, so it gives me my mean and standard deviation. It's key information you're going to need at some point, so just always write it in there and label well. And I'm looking for this x. Well, I can use this formula if I know z, and I do know z because I can figure out where the z is that has 90% lower than it. Unfortunately, I look on the table and you'll see the closest I'm going to come is 0.8997 because I only go to the hundredths place in the z's. I'm going to get 1.28. I'm going to go ahead and put that in and solve for x, and I get x equals 119.2. 119.2. 10% of the population scores higher than that on this IQ test. Whoops. Where am I? I'm here. Sorry about that. So on the calculator, we're going to do this on the calculator, but I still want you to draw the picture first. Draw the picture, and then if you have the proportion and you're looking for the point right there, the x, you're going to use the inverse norm. Okay, so watch the calculator video, read the calculator handout, and ask questions if you have them. But the inverse norm is part of the distro menu. So you press the second key and then the vars key. And it's the third choice, inverse norm. You'll put in the proportion to the left, the mean and the standard deviation, and then it'll come back with this. You see that they're very close. This is just a little more precise, and that's why we're going to do it, so we don't lose precision that we need. Okay, so we're going to use the same IQ data to find the bottom 20%. Very similar. I want you to stop and draw the picture, and then come back. Inverse norm is what we're going to use. It's 0.2 to the left, which you should see very clearly from your picture. 115 for the mean and standard deviation. And we get 87.3757. That means, interpreting that 20% of people have an IQ that's below 87.3757. And I cannot stress this enough. Always draw the picture before picking up your calculator. If you have questions, if you need help, the first thing I'm going to ask you is to see what you've drawn. See your pictures. There is going to be an assignment where you have to scan them and send them to me. So just get in the habit now. You have to draw the picture. Okay, let's do this last one using the IQ data. Find the IQ score at the first quartile. So now you have to remember all the way back to the beginning when we did the quartiles, and remember that quartile 1 has 25% of the data less than it. So pause the video right now and draw a picture that represents that. Get this curve, get it all labeled, and draw a line and put the proportions where they belong for the first quartile having 25% of the data below it, 75% above it. And now that you're back, we'll look and see that this is the calculator inputs that go with that picture. 0.25, that's the proportion to the left. That's what you'd have on your picture. 115 are the mean and standard deviation, and that gives you 89.8827. And again, I'm going to keep saying it over and over. Always draw the picture before picking up your calculator.